Let's take a look at curve sketching. Stewart, section 4.5. To sketch a curve, there are 5 steps we're going to complete. 2 non-calculus steps, 2 calculus steps, and then sketching the curve. First, we find the domain of a function that we want to sketch. That's all the stuff you're allowed to plug in. Probably easier to just take away from the reals all the stuff you're not allowed to plug in. Then you're going to find your asymptotes. Remember that vertical asymptotes are x values, where you have infinite limits. Make sure to take the left and right hand limits. And horizontal asymptotes are y values that you get from taking limits at infinity of your function and negative infinity. Please make sure to do both. Then you find all your first derivative stuff and your second derivative stuff, and then last but not least, you sketch your curve. We're going to look at the first 2 examples in class. Let's take a look at example 3. Now, first off, I always let my functions equal f or g or h or something besides just y. I also like to enumerate the steps, but you don't have to do that. But feel free to. So first off, the domain of f is, well, it's everything we're allowed to plug in, which is everything except 0. Next, we're going to note that x equals 0 is a vertical asymptote. And even though we know that, we're still going to take the limit from the left and the right side of 0 of f of x. And the reason is we want to see how f is behaving around there to sketch our curve. Now, I'll let you confirm this, but it turns out that both the left and the right-hand limits at 0 equal negative infinity. It's a negative infinity. So the double-sided limit as x approaches 0 is negative infinity as well. Next, to find the horizontal asymptote, we find that the limit as x approaches infinity of f of x, well, note that we can just, right, we're going to have an indeterminate form if we just do that. However, we can multiply the top and the bottom by 1 over x. And we see that we get 1 minus 1 over x, and that is 0. And similarly, I'll let you work this out, but if you take the limit at negative infinity, you're going to get 0 as well. And so that means that f has horizontal asymptote y equals 0. Okay? So x equals 0 is the vertical asymptote, y equals 0 is the horizontal asymptote. Great. Now let's get to our calculus. Now we want to let f prime of x equal 0, as we always do. F prime of x, that's going to be low d high minus high d low all over low squared. Now I want you to verify this through simplification, but this is going to wind up equaling 2 minus x over x cubed. Make sure to cancel out that extra factor of x when you simplify. And we're going to let this equal 0, and note that that's when x equals 2. Also worth noting, f prime does not exist when x equals 0. And that should not surprise us because f didn't exist when x equaled 0. 0 is not in the domain. All right, so f has one critical point, and that's going to be 2 comma 1/4. You just find that by plugging 2 into f of x. Not f prime, but f. Okay? Going to hold off on everything else right now until we find f double prime. Now, let f double prime of x equal 0 as well. Well, we're going to take that derivative, right? We're going to get low d high minus high d low all over low squared. And again, I'll let you figure out the simplification, but it's going to wind up equaling 2x minus 6 all over x to the fourth, and that equals 0 at x equals 3. Also worth noting, f double prime does not exist at x equals 0, which again makes sense because f does not exist at x equals 0. Now, I say it's worth noting, it's critically important. You have to note where f prime and f double prime are 0 and do not exist. And what I'm going to do at this point is get our interval chart going. And I'm going to try to do it right over a set of axes. So we know that both f prime and f double prime have critical numbers 0. F has that value 2 that's also of interest, and f prime has that value 2, and f double prime has the value 3 that's of interest. Let's just get our axes going, right? Just maybe put those numbers down. We know they're going to be important. And maybe so we don't forget, we could also note that our vertical asymptote is x equals 0, and our horizontal asymptote is y equals 0. Now let's see what's going on here. F prime. What happens if we plug in a negative number into f prime? Well, that's going to be positive divided by negative, which is negative. Plug in the number 1. That's going to be positive over positive. Plug in some other positive number. That's going to be negative over positive. So you get that. For f double prime, right, we're looking at this now. Plug in a negative number, you get negative over positive. Plug in 1, you again get negative, or sorry, you get negative over positive. And then you plug in a positive, you get that. You plug in a bigger positive, you get that. Now, before we sketch our curve, maybe we should just note a couple of things about our curve first. F is increasing on 0 to 2 and decreasing on negative infinity to 0 union 2 to infinity. F has, now keep in mind, there is no local minimum right there at 0 because f does not exist at 0. So f has a local maximum. F of 2 equals 1/4. F is concave up on 3 to infinity and concave down on negative infinity to 0 union 0 to 3. F has an inflection point 3,2/9, right? And again, I got 2/9 by plugging 3 into f of x. Okay? Now we're going to sketch the curve, keeping in mind our asymptotes. So the negative, negative, that's going to be that kind of a curve. So we've got that right there. The positive, negative right here is going to give us this, keeping in mind that we've got this critical point. Then the negative, negative is going to decrease slightly, right? We've got this point of inflection here, 2/9, so it's a little bit less than 1/4, and then we get that. Okay, that's our curve.